Hi, my name is Corey Yeager. I am the Director of Operations at EB Industries. And today I'm going to walk you through the three core processes that we offer at EB Industries, which are electron beam welding, and laser hermetic sealing. And we'll be going through some tips and just some general knowledge about each of the processes. So the first process we're going to talk about is electron beam welding. Electron beam welding is delivered with a large amount of power. There is so much power in an electron beam welding system that there is a process that is called electron beam machining, and there is enough power in the machines to simply vaporize the metal. EB welding machines come in two power ratings. There are low voltage machines, which are 60 kilovolts, and high voltage machines that are 150 kilovolts. A typical high voltage machine is rated to 15,000 watts, is capable of producing a weld that is 3 inches deep in steel with a width of approximately 10% of the penetration depth. The electrons can only be accelerated under high vacuum, meaning that the welding must be done inside of a vacuum chamber. So the one limitation of electron beam welding is that the size of the part to be welded is limited by the size of the vacuum chamber that you have. So the use of the vacuum, as well as the ability to eliminate the scattering of electrons and oxidation materials that can damage the weld itself, it also produces radiation. So that is why the handling must be done inside of a chamber, which is typically controlled externally using CNC tables. So the EB welding, because of all this technology, the high voltage machine and the vacuum chamber itself, the EB welding must be done with a well-trained and skilled operator, along with an engineer and an inspector. And there are also typically maintenance technicians that we have on staff to make sure that the machines are operating efficiently and limiting downtime as much as possible. These machines are typically in the millions of dollars, and the support to keep these machines running is very extensive, especially if you are relying on outside vendors to help with the maintenance of your machines. So when you have jobs that are as critical as ours that are required to be delivered immediately, we cannot afford to have our machines down, which is why we have several engineers on staff that are working around the clock to keep our machines up and running and maintained properly. So to summarize the science of electron beam welding, free electrons flow through a tungsten filament. This is done under vacuum by accelerating the electrons with a high voltage power source. Their path is controlled through magnetic lenses that could basically deflect the beam or control the shape by controlling the diameter, which is done by doing it through a narrow adjustable cone. By colliding the electrons with metal, the kinetic energy is transferred into heat on the workpiece, therefore producing a weld. The success and quality of the final weldment depends on proper joint design. Along with the joint design, we also have to make sure that the tooling is made with proper design limitations, because the ability to manipulate the part inside of the vacuum chamber is very, very critical. The tooling is also acting as a heat sink to minimize shrinkage and warping by minimizing and controlling the heat going into the part. The tooling can also be designed to shield and protect against exposed wires, sensitive components, and things like that against vapor and weld splatter. The electron beam must be generated, focused, and aligned at the setup according to a weld schedule, which is done during the development process to produce the desired result, which is always designed by customer specifications. It must also be synchronized with things like feed rate to produce the width and depth, which is the penetration, as well as the heat input and cosmetic finish of the surface that you need. Electron beam welding is a process that is very good and skilled at joining dissimilar metals that would typically be otherwise unweldable due to differences in melting points, which results in intermetallic compounds that cause brittleness. So when you have these dissimilar metals and you're welding them with other processes, you might experience things like cracking because the melting points are different and they shrink and expand different rates. So the precise nature of the electron beam and tight heat affected area allow electron beam welding to melt the lower temperature material onto the unmelted higher temperature material, resulting in a homogeneous weld. An electron beam can be very accurate place, and the weld can retain up to 97% of the original strength material. That is also a benefit when we are not having to use filler material, which is typically used in other processes like TIG and MIG welding. Only once one cycle is complete and all parts in the chamber are electron beam welding, a technician or operator unloads the welded parts for inspection and loads another batch until the welding is complete. Electron beam welding systems can weld all weldable metals, as well as some metals that are not typically weldable. Electron beam welds are incredibly strong and pure. Impurities in the weld are vaporized, and welding in a vacuum means that there are no gases or air to react and cause oxides. And oxides typically lead to things like cracking. Now we're going to talk about laser beam welding. Laser welding systems can deliver a tremendous amount of energy very quickly and with pinpoint accuracy. The beam can be focused and reflected to target hard-to-access welds, and it can be sent down a fiber optic cable to provide a more homogeneous weld. A laser beam is generated by rapidly raising and lowering the energy state of an optical gain material, such as a gas or a crystal, which causes the emission of photons. Regardless of how the photons are produced, they are concentrated and made coherent, which means that they are lined up in phase with each other and then projected. The photons are focused on the surface of a part. Radiant heat couples the material, causing it to melt via conduction. Since the heating of the material starts on the surface and then flows down into the material, the depth of penetration per unit of power in a laser weld is less than that of an electron beam weld. Most of the power of a laser weld is wasted on heat and reflected off the surface. To overcome this problem, the laser can be pulsed, varying the power of the laser over time during the weld cycle. By pulsing the laser at high peak powers, the average power can be a fraction of the peak power and the part stays cool. And on highly reflective materials such as copper and aluminum, the peak power is used to break the surface and cause weld coupling. The power output of a laser can vary from a few watts to hundreds of kilowatts, and different types of lasers have different welding characteristics. As an example, the wavelength of a light produced by the laser can make it more suitable for some applications and less for others. Laser welding generally requires the use of a cover gas to keep oxygen out of the weld area and improve efficiency and weld purity. The type of gas used depends on the type of laser, the material being welded, and the application. Some laser welding applications may require a glove box to ensure complete gas coverage when a gas nozzle may not be able to reach areas of a part with complex geometry. The alternative to pulsive is continuous wave laser welding. As the name implies, continuous wave lasers utilize a laser beam that is on continuously from the start to the end of the weld cycle. Continuous wave lasers are useful for cutting applications or when weld speed is important. For example, an automated TIG machine might have a welding speed of 10 inches per minute, while a CW laser can easily run at 100 inches per minute. When laser welding, high feed rates per continuous wave is necessary to keep the part cool. So heating parts often use pulse welding when possible. This makes them a good choice for welding electronics packages, particularly those that are hermetically sealed. Minimal heat means that the weld can occur extremely close to sensitive electronic components and soldered joints without melting them. Lasers are also very popular for medical device applications, as the weld can be tightly controlled and consistent, which leads to minimal discoloration of the part and a cosmetically appealing weld that may not need post-weld machining. The third process we're going to talk about is called laser hermetic sealing. Electronic circuits exposed to corrosive conditions or required to have extreme performance characteristics are sealed hermetically into special packages. Epoxy gluing, resistance welding, soldering, electron beam welding, and laser welding are several other techniques available for sealing these packages. The disadvantage in the use of epoxies is that they often do not create a hermetic seal. Moisture migrates through the epoxy, destroying its hermetic seal. Resistant seam welding is a reliable process that has been around for many years, but it has several disadvantages. For one, the process requires the materials to be welded at high electrical resistance, and therefore it cannot be used to weld materials such as aluminum or copper. Second, the electrodes must be run in on several unwanted packages before production welding begins, because new electrodes tend to run hot until they've been burned in. Furthermore, resistance welding can only be used for a lap weld joint. Problems develop when solder sealing is attempted on larger packages. The process requires a whole assembly to be heated, and the use of low melting temperature alloys may result in the materials not being fully welded. Electron beam welding has many of the same advantages as laser welding, but electron beam welding systems require vacuum chambers, X-ray shielding, and a fill of inert gas after welding, with another sealing operation by conventional means after that. Reliability, minimal heat distortion, high processing speeds, a non-contact process, and the flexibility of CNC programming are just a few of the advantages that have pushed laser welding ahead of alternative methods. Typical weld penetrations can be adjusted within a range from 10 thousandths to 60 thousandths of an inch, depending on the configuration of the weld joint. The heat input to the part is kept to a minimum because of the laser's ability to deliver the power in precise locations. Depending on the type of material, some heat is conducted through the part from the weld zone, but the losses are minimal. Reflection losses also occur, especially in materials such as aluminum, copper, and gold. Initial reflection loss is high, but the first part of the laser pulse melts the surface, and absorption by this molten material can be up to 20 times greater than absorption by the solid state. The welding is typically performed in an inert atmosphere, usually consisting of a mixture that is 9% nitrogen and 10% helium with less than 100 parts per million of moisture and oxygen. This keeps the weld free of contaminants. Because the inert atmosphere is contained within the package, the helium can be used as a tracer gas for leak detection, eliminating post-weld pressure bonding. A slow flow cover gas should also be supplied through the beam delivery nozzle or through a side jet to keep debris from being deposited on the focusing lens. A glove box system is an enclosed workstation that can be sealed from the outside atmosphere while its interior is evacuated and filled with a purified inert gas mixture. Parts are loaded through a two-way isolated transfer chamber where they are prepared for welding and manipulated through to a similarly isolated weld chamber by outside operators using sets of gas-tight gloves. Electron beam and laser welding are fusion processes that can produce high-energy precision welds in a wide range of metals, including exotic and dissimilar metals that are hard to weld by conventional welding processes. Other types of fusion welding, such as arc tungsten inert gas, which is typically referred to as TIG welding, or metal inert gas, typically referred to as MIG welding, might be an option, but if your requirement is for precision, energy efficient, deep yet narrow, pure because no filler material is typically required, welds, then electron beam or laser welding are often the best methods of joining. Because the physical components that generate electron beams and laser beams can be CNC controlled, you have a highly repeatable, versatile joining technology capable of welding both the smallest and implantable medical devices, and yet also deliver the tremendous amounts of power required to weld large aircraft parts. These welds can meet or exceed all metallurgic, structural, or hermetic sealant requirements while meeting all cosmetic needs that eliminates or reduces post-weld machining. With proper planning and tooling, both processes can many times be more cost-effective than conventional joining technologies. And right here, we have a chart just kind of compares some of the typical things to consider when choosing one of these processes. I would recommend giving some time here to pause the video to look at this chart. It's very important, has a lot of critical information here. Now, which one to choose? Which process is best usually depends on the application. Electron beam welding was an accepted process in the aerospace industry before lasers were available. As a result, the specifications for EB welding for aerospace parts are complete and widely accepted. These specifications control all aspects of the process, including joint design, cleaning, vacuum requirements, machine qualification, operator training, and inspection criteria. Without the requirement for vacuum, laser welding is generally less expensive than electron beam welding. Other assemblies may have specific requirements that will dictate the process to use. By working closely with an experienced weld or development engineer, we'll help you decide the right process for your application. Now, just to give a little background on EB Industries, EB Industries is a full-service provider of electron beam welding, laser welding, and laser hermetic services, as well as a contract manufacturing company with a large network for value-added processes. We have been around since 1965. We have the ability to meet unique requirements of component fabrication companies by helping customers design, develop, and produce welded assemblies. EB Industries also provides and manages additional services to produce complete assemblies. We are located in Long Island, New York, in a 17,000 square foot facility. We cover all of the United States, Mexico, Canada, Israel, and many, many parts of Europe. Now, what do we do? Our customers rely on EB Industries as a single source solution for designing and developing difficult to weld parts and assemblies, as well as producing them in a long-term production setting. We help customers design with 50 years of history of solving the most difficult precision welding challenges. We have experienced engineers on staff, knowledgeable in joint design, metallurgy, and manufacturing. We also have CAD, CAM, and solid modeling capabilities. We also do a lot of work with development. We have a large selection of several different electron beam and laser welding technologies under one roof. We have a fully equipped machine shop for fabrication and tooling. We have an on-site metal testing laboratory. We do all of our own cross-sectioning and metallurgical analysis on site, as well as a full network of suppliers and service providers to take on additional drawing requirements. And of course, the final goal for all projects is production, which we do have operations designed for integration and management of customer supply chains. We are ISO 13485, ISO 9001/AS9100 certified, and we are also NADCAP accredited for electron beam welding. And we typically average around a week or two for order turnarounds with expedited services available upon request. Now, for our capabilities, we have 4 high voltage EB welders. We have a 5th one that will be online in the next month or so. We have 1 low voltage electron beam welder. Our max chamber size is 36 by 36 by 72 inches. We have 5-axis CNC control on several of our EB machines. And we also have optional real-time parameter monitoring on some of our machines as well. On the laser welding side, we have 10 laser welding systems that range from 50 watts to 4,000 watts. We have pulse lasers and continuous wave lasers, fixed optics and fiber optics, as well as multi-axis CNC control workstation for each. Now, for laser hermetic sealing, we have 2 laser welding glove box systems. They have automatic vacuum bake ovens that are allowed to be programmed to have the right vacuum bake profile required by the customer. And these environments are also computer controlled with parameter monitoring and data log. You can see just a picture on the left of all 3 of the processes in production. Now, along with our core competencies, we also offer a suite of supporting services. Our services focuses on our core competency of precision welding and engineering and associated services. So on the engineering side of things, we do weld engineering and joint design. We do tool design and fabrication. We can help with system designing and development. We also do material and component sourcing as well as metallurgical evaluation. Now, for our pre and post welding services, we offer services such as cleaning and assembly, pressure testing, heat treatment, NDT, such as X-ray, dye pen, mag particle, and others. We also perform contract manufacturing as well as supply chain management, as well as things like coating, anodizing, passivation, post-weld machining, and stress relief. For quality, we employ a unique quality management system designed to provide high-quality work product that meets the varied requirements of its customers and industry served. As a result, EV Industries is on the approved supplier list for many large OEMs and Tier 1 suppliers. And just to repeat some of the certifications that we have, we are ISO 13485, AS9100, ISO 9001, NADCAP accredited for electron beam welding, and we weld to AWS D17.1, AMS 2680, AMS 2681, and other specifications upon request. Our equipment is all certified to MIL Standard 1595A, and our welders are on the electron beam welding side are all trained to AWS D17.1, which is a NADCAP accredited process. We support many industries. Aerospace, space, and defense is our most popular in our industry that we really started our company based on. We provide services for commercial and military aircraft, aircraft engines, rockets, satellites, submersible componentry, sensors and controls, ordnance, and weapon systems. In the medical device industry, we provide services to manufacturers of medical instruments, surgical tools, implantable devices, artificial joints, and dental appliances. We also manage the manufacturing and supply chain processes needed to make a complete assembly. Now, outside of those industries, we also support the battery industry, RF and microwave, automotive, food and beverage, nuclear energy, oil and gas, green energy, private and government research, semiconductor, and other industries that require precision welding of metal parts. Now, what is the EV industry's difference? So the first difference that we have over our competitors is quick turnarounds. So we offer same and next day expedited services, being that we're at the end of the supply chain with parts that have already been manufactured, assembled, coated, passivated, things like that. We understand that delays occur before parts arrive here, so we work with our customers to help make up for lost time in the supply chain. We also offer engineering consultation. So we provide complimentary engineering consultation to help support weld joint design as well as part design. This provides our customers the highest chance of success and helps alleviate a lot of lost time in the design phase from the customer and lost money in terms of producing prototype designs that may not be applicable for our welding processes. Our third difference is our quality. So we are certified to many industry specifications that were listed earlier, as well as being NADCAP approved for electron beam welding. We are also listed on a number of approved supplier lists for large OEMs that can be provided as required. Now, for some services that we plan on offering in the future, the first one is TIG welding. So we are expanding our welding services to offer TIG welding. This will allow us to support a larger scale of manufacturing projects outside of those that we can typically handle today. We are also looking into handheld laser welding. to see if we could potentially merge the benefits of laser welding with a manual process such as TIG welding. This will allow us to bridge the processes between both. And we are also offering laser ablation, which we have a portable laser ablation system that is used to remove rust from customer parts, as well as to be used for internal maintenance. Now, this is a list of some of our customers, as well as our end customers. So this kind of scales several industries between aerospace, defense, and medical, as well as alternative energy. And again, more customers and certifications can be provided upon request. So we just wanted to thank you for your time. And of course, if you have any questions or you want any specific feedback on any specific parts or products that you were designing, feel free to reach out to our engineering team today. Thank you for your time.